Hello everyone, this is our project, Automatic Street Light Control using Arduino. Coming to the abstract of our project, the main purpose of our project is to switch on or off street lights without any manual operations. IR sensors and microcontroller are the main components of our project. IR sensor like our eye, which detect the presence of an object. Introduction of our project is an automatic street light controller is used to control the street lights turn on or off based on the light. Here we make use of LDR, a light dependent resistor, and an LED, light emitting diode, and an Arduino or a microcontroller. This is our block diagram. As you can see, 3 IR sensors are used in the left side, a regulator power supply, and a high power LEDs, which is used in the place of the street lights. And also we can use a microcontroller or an Arduino board as our main component. Hardware which is used in our project are a microcontroller and a IR sensors, light dependent resistor, and a light emitting diode. Microcontroller AT89S52 is a high density, low power, high performance bit microcontroller with 8 KB of ISP flash memory. The device uses microchip high density non-volatile memory technology and is compatible with the industry standard ATC51 instruction set and pinout. On-chip flash allows the program memory to be reprogrammed in system or by a conventional non-volatile memory programmer. This powerful microcontroller is suitable for many embedded control applications. The parametrics of this microcontroller are the program memory type is flash and the program memory size is 8, CPU speed is 4, digital communication like 1 UART, temperature range is 0 to 0, operating voltage range is 4 to 5.5, the pin count is 44. And IR sensor, an infrared sensor, is an electronic device that measures and detects infrared radiation in its surrounding environment. Active infrared sensors both emit and detect infrared radiation. Active IR sensors have two parts, a light emitting diode and a receiver. Light dependent resistor LDR. A photoresistor is a passive component that decreases resistance with respect to receiving luminosity on the component's sensitive surface. The resistance of a photoresistor decreases with increase in the incident light intensity. In other words, it exhibits photoconductivity. High power light emitting diodes, which are used in our project. A light emitting diode is a semiconductor light source, and LEDs are introduced as a practical electronic component in 1962. Working of our project is when there is low amount of light, the light automatically glows, and when there is sufficient amount of sunlight, it automatically turns off the street light. When we place a hand on LDR, that is not allowing any light on LDR, Arduino automatically turns on the LED. When we remove our hand on LDR, Arduino automatically turns off LED. Software used in our project is Keel compiler. The Keel C51C compiler for the 8051 microcontroller is the most popular 8051C compiler in the world. The C51 compiler translates C source files into relocatable object modules which contain full symbolic information for debugging with the MuVision debugger or an in-circuit emulator. Coming to the result, the main idea of our project is to reduce the wastage of electricity, and the street light corresponding to the IRs will switch on automatically when a vehicle passes. Conclusion is a simple project for saving power is implemented using auto intensity control of street lights using Arduino with slight modifications and enhancements. This project can be applicable for real-time use also. These are the references which are referred by in computer and in books. Let's go to the simulation part. The working principle of an LDR is photoconductivity, that is nothing but an optical phenomenon. When the light is absorbed by the material, then the conductivity of the material reduces and the light falls on the LDR, then the electrons in the valence band of the material jump to connection band. But the photons in the incident light must have energy that is superior than the band gap of the material to make the electrons jump from one band to another. Hence, when light having ample energy, more electrons are excited to the conduction band, which creates in a large number of charge carriers. When the effect of this process and the flow of current starts flowing from the resistance of the device decreases, hence there will be a increase in the voltage. Let's go to the simulation part. The software which is used for the simulation of our project is TinkerCAD software, and the components of our project are Arduino board, light bulb, for a photoresistor to detect the light intensity, power supply, and an NPN transistor, and two resistors. So these are the basic connections. As you can see, the NPN transistor is connected to the light bulb. This pink wire indicates the connection between the light bulb and the transistor, and it is also connected to the negative terminal of the power supply. It is seen as the green wire. It is also given to the ground of the Arduino, and the positive terminal of the power supply is given to the light bulb. And also the base of the NPN transistor is connected with the resistor just to give the extra resistance so that the transistor won't be damaged. And the other terminal of the resistor is connected to one of the digital pins, that is pin number 3 here. Coming to the photoresistor connections, as you can see, this is connected to ground again with a resistor here to prevent the excessive current going through it. It is also connected to one of the analog pins, pin number A5. So these are the connections of the project. Now, in order to program our Arduino, we need to provide a code, and to do that we need to write a code. As you can see, I have already written the code to reduce the time of explanation. And here LDR is connected to A5, which is purple wire. It is given over here, and since LDR outputs same voltage value, we are taking that LDR value here. And light is connected to pin number 3, which is connected to an NPN transistor, and that is given over here. Coming to the basic setup, light is considered as output because we are controlling the light based on the light intensity, and the light intensity is considered as input. And the light intensity is considered as input, which the photoresistor inputs to the system that is given here. Now coming to the loop, we take the analog read from the photoresistor, and if the values exceed certain threshold values, that is when there is a lot of light, the light is set to low. That is how a light bulb should work. So when there is sunlight, the light shouldn't be on, but when there is less light, the bulb should glow. And so that is the program. And to check the program is working or not, start the simulation. And as you noticed, the light intensity is less, so the bulb is glowing. Let's increase light intensity, and the bulb is still glowing because it is not that bright yet. Now I'm increasing the light intensity furthermore, and as you notice that the light bulb is stopped glowing. So this is our project, smart street light using the Arduino board. Thank you.